Assalamualaikum everyone. We are students from Group A4AS1204_7 will be presenting about volumetric analysis, titration of lactic acid and assessing acidity in milk. My name is Nur Aleesa Adlin alongside with my group mates Izyan Izzani, Marissa and Rabiatul Fara Ain.
Today, we want to discuss about introduction and definition of titration, principle of titration, introduction of lactic acid in milk, apparatus and setup, procedure of titration, advantage and disadvantage, precaution steps, and conclusion.
Now, the determination of acidity in milk leads to the quantification of this parameter in the various stages of the dairy chain to assess the quality and safety of the final product. Real fresh milk may contain low amount of acidity, while high amount of acidity may be associated with spoilage as a result of bacterial activity. The level of acidity can be supervised. The primary aging component of milk is derived from lactose, and the natural bacteria found in milk undergo fermentation, resulting in an increased level of acidity. Secondly, the knowledge of acidity level will help producers know how long milk is usable by consumers, hence helping to control of stock and in the process enhancing minimal wastage. So there's a few ways of how we can approach this situation. Acidity in the milk can be established using the titration method, which estimates the ratio of alkali which correlate with the total acids in the milk. Milk acidity determination via titration is one of the most common methods widely used to estimate the concentration of lactic acid. This process is vital in the dairy sector since it assists in the testing of the milk to ensure it is okay for human consumption. Let's take a look at the definition of titration. So what is titration? Titration refers to the process which are used to determine unknown concentration of a solution in which a standard reagent known as titrant is gradually added to a solution of analyte until the reaction is completed. These are usually indicated by a color change, a precipitate formation, or an electrical measurement. Indicator is a chemical defector of acid-base titration, and it functions to give color changes at or near the equivalence point. Two most common indicators are methyl orange and phenolphthalein. Methyl orange are used in the strong acid weak base titration, while phenolphthalein are used in the strong acid strong base titration, as well as weak acid strong base titrations. There is two types of titration, which is the direct titration and back titration. Direct titration is the direct addition of standard titrant to the analyte in the presence of acid base until the reaction is complete and reach the end point. Meanwhile, back titration is when the excess of standard solution used to consume the analyte is determined by the titration with a second standard solution. Next, let's take a look at the principles of titration. So as we can look at the setup as shown, titration involves a few main apparatus such as the burette and conical flask. In the burette is where the titrant reaches the known concentration, or in this case, sodium chloride, are filled in. And in the conical flask are analyte, which is the unknown concentration, or in this experiment, the milk sample, are filled in. The titrant will be gradually added to the analyte using a burette which allows precise measurement of the volume of titrant used. This process should be slow and controlled, especially near the equivalence point to avoid overshooting at the end point.
Hi, my name is Izyan Izzani. Today I will demonstrate the process of determining lactic acid content in milk using a precise titration method with sodium hydroxide. The necessary apparatus include a 15 ml burette for measuring and dispensing 0.1 sodium hydroxide solution which serves as the titrant. A 10 ml pipette is used to measure the milk sample accurately into a 250 ml conical flask. Distilled water ensures true mixing supported by a stand and clamp securing the apparatus. Phenolphthalein indicator is added to visually signal the endpoint of titration by turning the solution pink. This setup warrants precise measurement and clear results. To set up for titrating lactic acid in milk, first secure the burette on a stand and fill it with sodium hydroxide solution. Use a pipette to measure 10 ml of the milk sample into a conical flask. Add approximately 50 ml of distilled water to the flask, followed by 2 to 3 drops of phenolphthalein indicator, which initially keeps the solution colorless. Slowly add sodium hydroxide from the burette to the milk mixture while gently swirling the flask. Stop adding sodium hydroxide when the solution turns a light pink color and maintains this shade for at least 30 seconds. Record the volume of sodium hydroxide used at this point. Repeat the titration process until you obtain at least 2 consistent readings, ensuring accurate determination of the lactic acid concentration in the milk sample. And this is the example of calculation. To calculate the lactic acid content in milk through titration with sodium hydroxide, we start with an initial sodium hydroxide volume of 0.00 ml in the burette, which after titration, it reaches 15.50 ml. The amount of sodium hydroxide used is simply the differences, which is 15.50 ml. Given the 0.1 mole concentration of sodium hydroxide, we convert this volume by moles by multiplying by 0.1 and dividing by 1000 to convert milliliter to liter, resulting in 0.00155 moles of sodium hydroxide used. Because lactic acid react with sodium hydroxide in a 1:1 ratio, the moles of sodium hydroxide used equal the moles of lactic acid in the milk, totaling 0.00155 moles. To find the mass of lactic acid, multiply these moles by the molar mass of lactic acid, which is 19.08 gram per mole, which is give us approximately 0.13962 grams of lactic acid in the milk sample.
So next, we are going to discuss about lactic acid. What is lactic acid? Lactic acid is chemical that our body produces when our cells break down carbohydrate for energy. We might see it refers as lactate. Muscle cells and red blood cells makes the most lactic acid, but it can come from any tissue in our body. Most people think of lactic acid in their muscles during a tough workout. Our muscles do produce lots of lactic acid when we are exercising, but that's not the only activity that can create it. Anything that makes our body use more oxygen than usual can cause our cells to produce lactic acid. So, lactic acid has three main functions, include energy. Our body makes lactic acid to full cells when they are working harder than usual. Second, generating glucose. Our liver and kidneys filter lactic acid out of our blood after it creates in other tissue. They break it down and convert it to new glucose that our body can use for energy in the future. And lastly, molecular signaling. Lactic acid in our blood is a signal molecule throughout our body. Think of it like a set of flags or markers a construction crew puts down before they begin working in an area. Lactic acid attracts cells in our immune system to heal wounds and fight infections. Next, understanding of lactic acid in milk. Lactic acid is a natural byproduct of lactose fermentation, serves as a key indicator of microbial activity in milk. The presence and concentration of lactic acid can directly influence milk's taste, texture, and shelf life. It's a clear marker of the product's freshness and overall quality. There are some functions of lactic acid in milk. First is safety and compliance. First and foremost, lactic acid testing is vital for ensuring food safety. High level of lactic acid, often seen in bacterial contamination, will pose health risks to consumers. Lactic acid produced from lactose fermentation by microbial activity remains unchanged by high heat treatments such as in UHT milk, thus providing data on the food product's history. Second is shelf life optimization. Understanding the dynamics of lactic acid formation helps in predicting and extending the shelf life of milk. Effective management of lactic acid levels through temperature control and fermentation management can significantly enhance product longevity, reducing waste, and improving cost efficiency. And lastly, quality control. Furthermore, lactic acid levels directly impact the sensory attributes of milk, such as sourness and consistency. By controlling these levels, producers can maintain the desired quality and consistency of their products, meeting consumer expectations. Regular testing allows for adjustment in processing and storage conditions, optimizing product quality.
Next is advantage of titration. It is a highly accurate and precise procedure, typically outperforming instrumental methods. It requires only a small sample size and volume of reagents. Multiple components can be titrated in the same solution without interference from indicators. So next is disadvantage of titration. Accurate performance needs extensive skill and training, particularly for manual titration. Titration sensitivity may be limited, particularly if the endpoint is not well defined or if the reaction is not extremely sensitive to detection. Temperature, humidity, and contamination can all have an impact on titration's accuracy. Next is precaution by using titration. Firstly, handle chemicals with care. Wear protective gloves, goggles to prevent skin contact and eye irritation, and wear a lab coat. Maintain proper temperature. Temperature control is essential in titration. Use a suitable indicator. The indicator used in titration should be suitable for the reaction being performed. Avoid over-titration. Over-titration can produce erroneous results. And lastly is dispose of waste properly. Dispose of waste generated during titration properly to prevent environmental pollution and ensure a safe working environment.
In conclusion, titration of lactic acid is a valuable method for assessing acidity in milk, providing quantitative data that is crucial for quality control in dairy production. This analytical technique enables a precise measurement of lactic acid levels, which directly correlates with milk freshness, taste, and compliance with regulatory standards. By leveraging titration, dairy producers can ensure consistent product quality, optimize manufacturing processes, and maintain consumer trust by delivering milk products that meet desired acidity levels and safety requirements. Thus, titration of lactic acid in milks plays a pivotal role in ensuring both the quality and safety of dairy products in the market. So this is our reference. Thank you for listening to our presentation.